Alright, GIS 300 students, we are going to dive into a real-life analysis of forest interior modeling. Forest interior is usually defined as a forest that is more than 100 meters away from the edge. Edge being a gap. That could be a forest road, that could be a recent forest harvest, that could be a lakeshore. These locations are usually moister, quieter, cooler, and a lot of species depend on them for habitat. We want to know where they are, we want to know how much we have. We're going to use a LiDAR-derived canopy height model to do it. If you don't know what LiDAR is, I would like you to pause this video and go ahead and watch the intro to my map and LiDAR interpretation class, which I'll provide a link to in the Brightspace. It's also on YouTube. I'll put a link in the description. I have that stored in my week 6 data under canopy height model, which I'm going to double click and bring in. This side is Baxter State Park. This side is privately owned. Zoom in. You can see the trails from a recent harvest. This is a 1 meter resolution model, and you can see the individual canopies of the trees here. Let's reclassify this for a better look. Double click. Instead of single band gray, single band pseudo color. Let's go ahead and use the magma color ramp. So when we hit apply and OK, you see the new color scheme where black is ground and the brighter shades of pink are taller trees. We can also see some artifacts in this data set. These lines are not real. Those are present throughout this image, but it's not going to be a problem for this analysis. So what we're fundamentally doing is looking for gaps in the canopy, and then looking for locations that are a certain distance away from that gap. We're going to make it so the gaps have to be a certain size to count, because if you zoom in, see all these little gaps. Those don't count. Those are just the size of an individual tree. We're looking for a real opening like this lakeshore, or that road. Our first step is to reclassify this data set. Reclassify by table is what we just used. We'll use that again. And we need to create a reclassification table, and we're going to make a 2-row table. The minimum is 0, and the maximum we're going to say 4 meters. That is going to get a value of 1. Anything greater than 4, so 4.00001 to 50, which is the highest value in this model, gets a -999 or no data. So it's either a gap where the trees are less than 4 meters in height, or exactly 4 meters, or we don't care about it. It's something else, it's forest. Now we hit OK, and that's fine. And as before, we're going to change that so the zeros count. And we're going to save that to a temporary file. Run. Think. Going pretty quick for me. It'll be a touch slower for you. There you go. And now I'm going to uncheck that, and that leaves us with only these areas. Now see, we do have some errors here, and that's where the LiDAR pulses are bouncing off the lake. There are ways to fix that, but that's not what we're doing right now. We're just going to accept that there's going to be some error here, and we're going to work with that. So we'll just have to remember that at the end. Next, we need to know gaps of a certain size, meaning that we don't want these, we want these. None of these cells know what they're associated with. They don't know if they're a lake, they don't know if they're forest, a little gap between trees. They know exactly nothing. They don't know if they're part of a big thing or a little thing or completely on their own. We need to turn this back into a polygon, into a vector feature. Then we can calculate the area of that and select on that basis. So we're going to go under Raster, Conversion, Polygonize, Raster to Vector. Our input layer needs to be our reclassified raster, and the rest can remain as is. Run. Alright, so 2.5 hours later we have it, so I'm not going to give you a full resolution version of this. I'm going to cut this down to either a 2 meter or a 3 meter resolution. That'll make it go between 3 and 9 times faster, and I'm going to give you a smaller piece so it doesn't take you 2.5 hours, or probably 10 hours, as the case may be. So once we see this output, I'm just going to give you the most interesting part. So, close. And now, uncheck that, so vectorize is down below here. So you see how now every one of these is a polygon. Every one of those polygons has an area, and the area can then be used to sort out which ones are big and which ones are small. So I don't care if a forest is somewhat close to one of these small patches. I care if it's close to one of these. So I'm going to right-click on Vectorized, open the attribute table, and once that opens up, I'm going to create a new field, and that new field is going to be the acres, or in this case, the square meters. So that took a little while to load up, and that's okay. So what I'm going to do is hit this button here for Open Field Calculator. And then I'm just going to do $area, lowercase. Double click there. I'm going to call that square meters. And that's all we need. Okay. And you see that took a while too. And now we have a field with square meters, or the area in square meters, of every one of these polygons. And now I'm going to select only those polygons that are over a certain size. I'm going to do that with this select features using an expression. And this is moving slow even for me. So when you're doing this, you want to just give it time, click once, wait for it to do its thing, and then carry on with the next step. If you click a bunch of times, the whole thing is going to stop responding and probably crash on you. The way I write this is start typing in SQ and then select here, so I have SQ meters. Double click on that and then greater than. And I'm going to use greater than 2,000 square meters. That's about half an acre. 2,000. Select features. This will take some time too. That selection is done now, so I'm going to close that and see all of these not selected, but the big ones are selected. If we zoom out, you'll see which ones are selected. All of this partial harvest here, that whole pond, that area there, I'm going to try to correct that for you by the time you get to it, so you might not see that. But we've not selected these little tiny patches, these ones that are under about half an acre. And that's one of the two moving parts in this analysis. The one moving part is how tall does it have to be before it's no longer a gap. We used a threshold of 4 meters. The other moving part is how big does the gap have to be before it is a gap. Like, is that a gap? Is that really big enough to be interrupting forest interior? Maybe, maybe not. That's really a question for an ecologist. And that might vary by system, but I think for now a half an acre, 2,000 square meters makes pretty good sense. So let's move on with this. Next step is right click, export, save feature as, save only the selected features, and we'll save that in week number 6, no, FOR 242, GIS 300, week number 6. And that is going to be called gaps 4 meters over 2,000 meters.shp. Good descriptive file name. Save. Everything else is good. We have UTM zone 19 north. Okie doke. Very good, that worked. And that took about a minute for me, so probably a bit longer for you. So patience, patience, patience on that front, but it should go faster when I give you the smaller data set. So now our new layer is only those gaps that are greater than half an acre. And you can see the display is struggling a little bit with all the different boundaries on here. So you see how it draws first the interior and then the boundary? We can make it go a lot faster by double-clicking, going to Simple Fill, and then Stroke Color, Transparent Stroke. Okay. And now it's just that boundary. Now it goes twice as fast. And you get a cleaner display when you're zoomed out. And you can see some of this artifact that we noticed before. You see that straight line? That's not real. So that's part of the artifact from the LiDAR dataset, this one as well. But you'll see in a moment why that still doesn't matter, at least in this particular analysis. So right click, zoom to layer, see the whole thing. So we can see gaps caused by harvesting patterns here and gaps caused by natural features over here in Baxter State Park. Next step is to create a buffer around this, and that's Vector Geoprocessing Tools Buffer. So remember, the forest interior is more than 100 meters away from a gap. We have to find the gaps, and now we need to define that distance, 100 meters. We do want to dissolve the result. And now, run. Now, I don't know how many of you are old enough to remember this, but this film has been modified from its original format. It has been formatted to fit your screen. So even on my fancy computer, this one got hung up and it's been on 75% complete for the past 3 hours. So we're not doing that. What we are doing is working with a 10 meter resolution version of this same model. So that's 1 meter resolution, that's 10 meter resolution. That's the reclassified model at 1 meter resolution and 10. Zooming in, 10 and 1. The 1 meter has all these edges to calculate off of when it's doing the buffer. The 10 meter is going to be a lot simpler. The results will be broadly similar, but will actually run on your computer. And mine before midnight. Now before, when I've done this for whole townships, I just let it run for a couple of weeks, and that's fine, but we're not on that timeline. Conversion to polygons in under 40 seconds. Now I've done a selection here, and you can see that this is a less contiguous system here because of the way this is broken down. So instead of 2,000 square meters, I'm going to select by 1,000 square meters. See how this changes. There's with any polygon greater than 1,000 meters selected. Here are our gaps with a 10 meter resolution model with a 1,000 square meter minimum size. And here is the same, done with 1 meter resolution and the 2,000 meter minimum size. You see how there's so much more connectivity between all these. That's why I reduced the size, but you can also see how much more complicated this feature is, that this is why the buffer was getting hung up. Now in here, there'd be very little difference in the output, but this here, because there's no gap extending out into here, this is going to be a difference, that this is something we've lost in this resolution change. On the other hand, that is going to get buffered out. That wasn't there before. So that might end up coming out in the wash. In any case, we're learning about raster resolution. And I've also cut it down to a slightly smaller area. And that buffer took 1.25 seconds. Now let's bring our gaps up above our buffer here, and you can see what's going on. All of these are gaps in the forest, and anything that's within 100 meters of a gap is not forest interior, whether that gap happens to be natural or man-made. But we can't really work with the areas that aren't. We need to have an actual layer that defines what they are. We need a layer that represents the actual extent of our gaps, the area for which we have data. Vector, Research Tools, Extract Layer Extent. The input layer is our gaps over 1,000 meters in this case. And I'm okay with creating a temporary layer. You may choose to save to a file. Run. Close. Now we have a polygon that represents the area for which we have data. Let's move that down below the buffered area. And we can see this is all the forest interior. We need to essentially use this as a cookie cutter, this buffered layer as a cookie cutter, to cut out those parts that are not forest interior. That's the whole reason we made them. Vector, Geoprocessing Tools, Difference. Input layer is our extent. Overlay layer is buffered. Run. Close. Let's uncheck everything. Our difference is our forest interior, where forest interior is defined as those locations that are more than 100 meters away from a gap, which is 1,000 meters in size, and less than 4 meters in height, when that height is the height of the vegetation. So if it's greater than 4 meters in height, that's considered mature forest in terms of this analysis. So the two moving parts in this analysis are how big is the gap, and how tall does the vegetation have to be before we consider it to be mature forest again and not part of a gap. And we can see on the side of the park we have some natural gaps and a lot of forest interior. And in the privately owned side we have forest interior here, 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 and here. But most of this, until it regrows, is not. In time these canopies will grow, these will close together, the regeneration in these trails will come up and exceed whatever thresholds we set for mature forest. They'll be greater than 4 meters in height. And when that happens, that will again meet the criteria of forest interior. With this background set to transparent, we can see a bit better how it works. And we can see some potential flaws, like this natural feature is defined as a gap, but this road is not. And is a new or actively used road different from an old one? That might vary by species, just how old the road is, what kind of forest type it's in, any number of factors. But we can change those variables to suit, and if we want to draw a line in here, buffer that, and add that to the buffer we used to define that, we can do that too. But this gives us a repeatable, verifiable way of calculating this metric of forest interior on a landscape wherever we are. We define it, we measure it. If we need to remeasure it, we can change whatever input variables need to be changed and recalculate that to suit whatever needs to go into it.